Okay, a couple more examples in this video of area between curves. This one we've got a graph where, again, we've got to find a shaded region and it's given to us, but what we might notice in this question is that we've got two graphs and an area where the graphs, somewhere in the interval of area that we're finding, which from the graph looks like 0 to pi, the graphs actually cross over, okay? And if that happens, then what you have to do is evaluate the areas separately, because for this first region, we have the function, in this case, it's cos of x on top and sine of x on the bottom. But in this second region, we've actually got sine of x on top and cos of x on the bottom. And in these cases, we have to set up two separate integrals to find two separate areas and then add them together. So let's call this area, this could be area 1, and this larger area can be area 2. All right. Before we evaluate the areas, what we're also going to need to know is where do these graphs actually cross over, because that gives us one of the terminals for our definite integral. So we need to find this x value where the graphs cross over. So to do that, well, let's say the intersection, they're going to intersect when the functions equal each other. So when sine x equals cos x. Now, you might be able to solve that equation by inspection, because the angle where sine of an angle is the same as cos of an angle is actually pi on 4. Both sine of pi on 4 and cos of pi on 4, they both equal 1 on root 2. So you can solve the equation by inspection. If you didn't immediately pick that up, well, what the other trick you could use is to divide both sides of the equation by cos x. And that will give you sine x over cos x is tan x, cos x over cos x is 1, and tan x equals 1 when x is, if we think about our triangles, when x is 45 degrees or pi on 4. So whatever our approach is, we get to the point where we know now that x equals pi on 4 is where the two graphs cross over, and that gives us then a terminal that we're going to use for both integrals. So let's find each area now. I'm trying to keep the working neat because there'll be a lot of it. So let's say area 1 is equal to, so it's going to be the integral, go back to the picture, from 0 to pi on 4. So the integral from 0 to pi on 4 of the function. Now, the one that's on top in this region is cos of x, right? Cos of x is on top and sine of x is on the bottom. So it's the integral of cos of x minus sine of x with respect to x. All right, so now, as always, we're just going to go and evaluate this integral. So the antiderivative of cos x is sine x. Antiderivative of sine x is negative cos x. So this becomes minus negative cos x, which gives us plus cos x. Okay, and now we sub in and solve. So sub in and subtract. So we get sine of pi on 4 plus cos of pi on 4 minus sine of 0 plus cos of 0. All right, so a bit of exact values practice here for us. Sine of pi on 4 and cos of pi on 4 are actually both 1 on root 2. And using the unit circle, sine of 0 is 0 and cos of 0 is 1. And so this area is equal to, well, we've got two lots of root 2 here, so we've got 2 over root 2 minus 1. Okay, so that's the area of the first region as an exact value, and there's no indication to round in this question, so we'll keep our answer as an exact value. Let's go back now and find this second area. So this second area, let's call it area 2, is going to be equal to the integral from pi on 4 to pi. So those are our terminals. But in this region of the graph, sine of x is above cos x, so we call it sine x minus cos x. That's what goes into the integral with respect to x. There is a section of the area that's below the x-axis, but actually when you're finding the area between two curves, that doesn't matter. Okay, so for area between two curves, it's always just top function minus bottom function, and you set it up as one integral. And without wanting to make it too complicated, the reason that this works is that because if we think about this, if we're subtracting the area of the bottom function, but that's below the x-axis, well, that's actually going to cause us to subtract a negative number, which really means we're going to add on this area, which is what we want to achieve anyway. So, like I said, don't get too hung up on that, but just be mindful that when you're finding the area between two curves, it really doesn't, the approach doesn't change if some or all of the area is below the x-axis. Okay, so again, we've just got a definite integral to work out, so let's do it. We already know the antiderivative from what we sort of do. We did the reverse of this function before when we did the antiderivative. So antiderivative of sine x is negative cos x, antiderivative of cos x is positive sine x. So for this second integral, we've got negative cos x minus sine x as our antiderivative. And again, sub in the terminals and work out our answers. So negative cos of pi minus sine of pi minus negative cos pi on 4 minus sine of pi on 4. Okay, so let's think unit circle, cos and sine of pi. Well, pi puts us over here. So cos of pi is negative 1. This already has a negative sign in front of it, so it's actually negative 1. That makes positive 1. Minus sine of pi, and the y value at pi is 0, so sine of pi is 0. Minus cos of pi on 4 is 1 on root 2, so negative 1 on root 2. And sine of pi on 4 is also 1 on root 2, so minus 1 on root 2. And this gives us 1 minus negative 2 on root 2, which becomes 1 plus 2 on root 2. So comparing the two areas, you can actually see that there's some similarities in what we worked out. The first area is root 2 on 2 minus 1. The second area is root 2 on 2 plus 1. Kind of makes sense. The second area had to be bigger. Okay, so that seems like a logical or two logical answers. Final step after all that is obviously to then say, well, what's the total area? And the total area, of course, just equals area 1 plus area 2, which is 2 on root 2 minus 1 plus 1 plus 2 on root 2. So we actually end up with 4 on root 2 from adding those two together, and the minus 1 and plus 1 cancel each other out. So we get 4 over root 2 as our final answer.